when we're discussing the soil volume characteristics, we're talking about when soil is moving from different conditions. Those conditions that we're talking about is moving from the bank condition, which is the initial condition that you can find it in, right? And then if you were to dig a hole, or maybe you excavate, let's call it like that. You excavate soil, what's happening is the soil will swell, right? When the swelling takes place, and then it means that the soil is now in a loose condition. In that condition, then you can move it to a compacted condition. Let's say you take the same soil and you try to take it back to the same hole that you just excavated. If the soil is not compacted, it will not fit, meaning that you'll have excess soil on the side. So how do you take it back? If you wanted to go back to the maybe the whole volume of soil to fit in that hole again, what you need to do is you need to compact the soil so that you take it back to that condition. So that condition we call compacted condition. Right. So there are things that you need to note, that you have soil in its condition and then its bank condition. If you excavate it, it becomes loose. If you compact it, then it will go back to the compacted condition. In the process whereby you're excavating it, it's moving from the bank condition to a loose condition. The process that happens there will be the swelling. If you take it back, what you're doing is you're moving it from loose condition to a compacted condition, and what's happening is shrinkage. So in your book, they kind of explained, and also in the last recording that we had initially on soils, this information is explained. So today what we're going to do is we will be focusing on the calculations. There are a few things that I need you to note. That's why I said open your books. Right now, I would like you to go to page 28. When you get to page 28, you will see that there is a part that says swelling or bulking at the top. That's where that's the first equation that you have. It says swell in percentage equals the mass in terms of the bank over the mass, and then they talk about the loose condition in terms of volume, right? Minus 1 times 100. The swell equation is correct, and the shrinkage equation is correct. When you move further down, where they speak about conversion of material volume, right? There are load factors. So we use load factors to move from each condition. So, for example, when you move from when you move from a loose condition to a bank condition, you will have a load factor, right? So what's happening there is you have a load factor, and on the book they say compacted volume. It should be loose volume over BM. So the first one, where there is a load factor, scratch out CM and make it LM cubed, not CM cubed, but LM cubed. That's the first one. The second one at the bottom for the shrinkage factor, when we're dealing with the shrinkage factor, we are converting the bank condition to the compacted condition. So that's why you have BM cubed over CM cubed. The same way what you have up there. They say load factors, they say transported materials and spoil banks are normally expressed as LM cubed, which is loose. And the load factor is a convenient way to convert LM cubed to BM cubed. But on the formula, they now talk about CM cubed. It was a mistake. That's why for the load factor, you should have LM cubed over BM cubed. The same thing happens for the shrinkage factor, because what are they converting? They're converting from BM cubed to CM cubed. That's why you will have BM cubed over CM cubed. So essentially the examples on example 3, on page 29, they have an example there, and then they have a solution. Those formulas on the solution are correct. You need to make sure that they're the same for the load factor and the shrinkage factor. Just correct them. Is there anyone who does not understand or anyone who's lost before we move? Okay. If no one is lost, then we're going to do one example. So you already have an example in your book. If you look at the example that you have in your book, you can go through that example on your own. It's fine. So they say here a soil mass is 1,163 kilograms per meters cubed. And then you have also the volume, the mass in terms of the bank condition and the compacted condition. What they want is for you to determine the load factors, right? The load and the shrinkage factor, meaning that with the information that they gave you, you need to get the load factor and the shrinkage factor. And then they ask you how many BM cubed and CM cubes are contained in a 5,900 5,933,000 LM cubes of soil, right? So what you need to do then is you need to apply the formulas that you have to get the information. So instead of doing that example, let's rather do another example, but you will still apply the same formulas and the same methods that they have in your book, right? So let's say that they say that a soil so this is the question that they have. They say that a soil mass is all that information, and then they give you the conditions that they want you to work with. And what they want you to do is they ask you Okay, do you all see the shared screen? Can you please indicate?
Yes, we can.
Okay, no problem. So this is what they have in a form of a question. They say a soil mass is 1,510 kilograms in loose condition, 2,424 kilograms in a compacted condition, and 2,008 kilograms in a bank condition. How many cm cubed are contained in 440,000 lm cubed of soil? So that's what they want you to determine the volume in terms of the compacted one. So you need to do that example. That's what we're going to move with. So with what they have in your book, right? Because if you look at the B, number B on your examples, they are asking you the information, but this question is different in a sense that it's not like you're asked maybe determine this, then determine that, and then after, if you have this and if you have that, how many cubic centimeters do you have in that form? So here they just give you the information and then they ask you the volume in cubic centimeters, and then that's what you need to determine. So I just need to give you 2 minutes, or maybe one of you will just indicate what do you think is a way forward of solving this question so that we can move. Or is there anyone who has an answer?
Can
If
you
you're
hear me?
not sure, yes, I can hear you.
Yes, I'm saying that we would use the factors. We would find the load factor and the load factor and the shrinkage factor, and then apply it upon the number which were given to convert it to the cm cubed and the bm cubed.
Okay, thank you very much. So if there's anyone who does not understand, just go back to your book and do exactly what he said. You need to apply, you need to determine the load factor and the shrinkage factor, and you apply that to get the compacted volume. If you still don't understand, it's there in your book. You will adopt the same method, right? So this one is an easy question. The number B on your example is the one that you need to use. So the only difference is that the volume changed, and instead of getting the question in a step, or in a, maybe you need to give one step, A, B, C, determine this, determine that, and then give this answer. What happens is you are asked to give the number B, which is the last one on your question. So just follow that. So this the calculation on its own, it's easy because it's just you having to understand what is it that you're converting to what, right? So are you converting the loose condition to a bank condition, or are you determining, or are you maybe converting the compacted condition to the bank condition? That's the only thing. And you need to also understand, or maybe put it in practice in terms of, will it make sense? If you're talking about the loose condition, if let's say maybe you need to determine from there the bank condition, you can't have a bank condition that is bigger than the loose condition, because we're talking about the soil in terms of volume. We said when you're excavating, you're moving it from a compacted condition, because the number of voids that you have there will be way less to what you'll have in the swelling state. It means that when the soil swells, then it has more voids in it. Therefore, it's not compacted. So in terms of volume, if you are determining the compacted volume, you can't have volume that is bigger than the loose condition, it means that there's something wrong. So when you're determining or you are doing that calculation, just make sure that the value that you get there, it will make sense to you as well in terms of what are you determining, and does it really make sense, or does it follow the theory behind what you're doing. So just make sure that you do that. And remember, because it's a simple calculation, it's easy for you to think that you have it, but you don't, right? So the one that I will explain and try to so that we kind of understand is the one that has where they talk about the spoil bank, right? And then maybe they talk about a spoil bank or stockpile. Sometimes they will refer it to as that. So what is a spoil pile or a stockpile? Is when you have that you have a site, right, that you need to excavate. Maybe you are digging a foundation, or you are just digging a hole for something you need to maybe have, or you're trying to build or whatnot. So what happens is the soil that you are excavating, right? You are excavating from that portion or that volume or area. The soil that you're going to excavate there, that is going to be your stockpile, right? Or the spoil pile. So there is a way that you can, so because you are digging soil, right? It will create a pile. This pile, let me just remove this. So you can also check in your books. So if, let's say, what they have also in your book is something like this. So let's just explain a few things, because there are formulas that you would need to apply, and how do you get to that? So this will be your pile of soil, right? So this will be your pile that you excavated, a pile that you would have excavated, right? This pile of soil, depending on the angle, you will have an angle here, right? Okay, let me try to draw it neatly so that we will be able to understand this. So this is what they're talking about. So this will be your stockpile that you excavated. Depending on how long the excavation is, right? So you will have the length, right? So you will have here, this is your pile. You excavated the soil here. It was initially in the bank condition. Now it moved from being a bank condition to a loose condition. If you're to take the same soil and you try to take it back into the trench, right? You need to compact it, or else you'll have excess soil. What's happening here is when you're removing it, it swells. You pile it together, but when you're piling it, you will have an angle. On your book, they have something like this, whereby they have extended lines here. Also on the side, they have here, and then they have a straight line. And then they tell you that this is the angle of repose. Basically, this angle that they're talking about is the angle here. So they have extended lines here, because here you can have a straight line. If you have soil that you're piling here, you might not be able to determine the straight line, but according to that, they correct that line, and then they'll have a straight line. That angle, they refer to it as R. That is the angle of repose. It means that it's the steepest angle that the soil can be banked, right? So this is the angle that they're talking about, the angle of repose. Because if you were to follow the rules of maths, right, this angle, that's what they have here, because this line will be parallel to this line. And therefore, if there's any extended line, straight line here, then it means that there is an angle here. It should be equal to that, because it will be corresponding angles, and therefore they're equal. So if you're able to get this angle being R, the angle of repose, it's the steepest angle that the soil can be banked, right? So that's the angle that they're talking about. So they have different formulas that they're referring to. So they will have, firstly, the height of the bank or the spoil bank, and then they will have the width of that, right? So they have then what they call the volume. So they tell you that to determine the volume, you will need the section area multiplied by the length. And then altogether, then they tell you in terms of V, they say breadth, height over 2 times L. And then they tell you to get the value of B, you will have 4V over L, and then tan R being the angle of repose, all to the power of half. And then you'll have the value of H. How do you determine the value of H? They say this is B tan R over 2. Right, so this is the information that they gave you. And they say this will relate if you have a triangular spoil bank. It will be different when you have a conical spoil bank, right? So when you have a conical spoil bank, then the formulas will be different. They are also noted on your book. So in terms of the volume, the volumes will still be the same when you have a triangular spoil bank, and then you will have a different formula. Those are the base formulas. The same way you will know, you know how when you have a cube, how do you determine the volume of a cube? This, that. So it's the same thing with that. So the base formulas you need to know, and then if there's any additional information, then it will be given. So the only thing that's different is that when you look in your books, right? In your books, they have an example. So the example that they have, they told you, because you already have the example in your book. So they tell you that you have find the base width, right? And height of a triangular spoil bank. So they tell you that you're dealing with a triangular spoil bank containing 76.5 BM cubes of soil. If the length is 9.14, the angle of repose is 37 degrees, and the soil is 25. So I'm not going to do the whole example because you already have it, but I want to explain something to you. If the information that you had in terms of the formulas that you have on page 28, when you look at this, because it's something that they did not, there is no formula for that, and you might be asking yourself, because this is a straightforward calculation, right? In terms of, you either need to know, do you have a triangular spoil bank or do you have a conical one? If it's triangular, then you need to apply the formulas that you have. If you have a conical one, then you will apply the formulas that you had. Same thing. It's not a problem. The only thing that is important for you to note is when they tell you there is a swell of 25%, right? And what do they want? They want you to find the base and the height. What was happening here is the soil, right, here moved because it was in a banked condition. And then they excavated the soil. They ended up with a pile that has an angle of repose. That angle of repose was 37. But they're telling you that because we know that soil swells when it's moving from the bank condition to a loose condition, then it means that you have a swell in a percentage. So what happens is the 25 that they're talking about, remember, there is this formula. When you go back to the previous page, they say you have a swell in a percentage, it equals mass BM cubed over -1 times 100. So what are they saying? They say that the soil moved from a bank condition, and it's banked condition, meaning that it was compacted maybe on a piece of land or site. Now they are changing it to a pile. What they're telling you that is that this soil moved from here to there, and there was a swell. This swell was 25%. So the 25% that they're talking about will be here. So when you see that calculation there, that has 1 plus 25 over 100, where are they coming from? It's not clear, but this is what you'll have. You'll have the 25% here equals the mass BM cubed over mass LM cubed -1, all of this times 100, right? So you'll just divide this, but the most important thing for you to note is what is BM cubed over CM cubed? We already know that BM cubed over the BM cubed over LM cubed. This is the L that we're talking about. BM cubed over LM cubed, we are talking about the load factor. So remember here, we said that this is the formula. The first formula that we spoke about, BM cubed over LM cubed. What's happening? They're moving soil from a bank condition to a loose condition. BM cubed over LM cubed, when you go to your book, page 28, you already know that this is a load factor. So what's happening here is the 25% is going to be equal to the load factor -1 times 100. This, when you divide by that, this will be a 0.25 load factor -1. And then you'll add that one. So that 1.25 will be your load factor. And then you will use that to apply it on the calculation so that you have the volume in terms of the loose condition, because you need to use that. So that's the only thing that might be tricky in terms of how do you determine, because they did not explain it, because the volume that you need to use in the formula, when you look at it, remember on page 31, they said that the volume that they're referring to, it has to be in a loose condition. And the volume that was given to you was in a bank condition. So even if you get the soil, they say, maybe you get an example. They tell you that this is, find the base or the width. This was the spoil bank, and we're giving you the volume in a maybe in a bank condition, and then they tell you that it's gonna shrink or anything. So what you need to understand is, how do you go about it is understanding that the base thing is you have soil in its bank condition. When you're moving it to a load factor, or when you're moving it, to a loose condition, the soil swells. If the soil swells, then you can calculate the swelling in terms of a percentage. There you will also have what we call the load factor as part of that calculation. So when you know that when you're moving from one condition to another condition, then there is swell and shrinkage. When you get a question, don't condition yourself that a question will always come in that way. It will come in different ways. And sometimes they might not ask you to determine the base or the height. They can ask you to determine everything. So because the calculations themselves are straightforward, then you need to understand or find out or maybe try to learn or maybe investigate what is it, how can they ask this question if not in the way that they asked it in the book, right? So that's all. But you just need to know that the calculations will be formula based, but you need to know what kind of spell bank are you given. If you're not sure, then you just need to look at the formulas and see how they are different. For instance, when they're talking about the triangular spell bank, you have the value of V, B, and H. On the other side, they have the value of V, D, and H, right? So, but it's not like anything is different in there, because you just need to know what are you dealing with, what is the volume, and how do you determine the volume? What do you need to determine the volume? If you already know the information, then you're okay. If they say that they're giving you a conical spell bank, what happens is, if it's a cone, right? Then you need to know that how is it different from a triangular, because then you just need to look at what is a triangular prism and what is a conical shape. Then you just determine from there. That's the only thing. But the base, in terms of the base determinations, then it will be easier for you to determine those because you already know. Then you just need to know which formulas you apply. Also, you need to know, even if the formulas are given, the formulas will be given, but it will not be, it's not like I'll say, these are the formulas if you have a triangular spell bank, and these are the formulas if you have a conical spell bank. You'll just be given formulas. You need to know, these are the formulas I use if I have a triangular spell bank, and these are the formulas I use when I have a conical spell bank. But that's the only thing. In terms of the calculations, they are straightforward and they're formula based. So is there anyone who does not understand, or do you have any questions? No questions. Okay. If you don't have any questions, then it means that for this one, we will stop here, and then we're going to continue at 2 o'clock, and we will be doing the last part of concrete, including the concrete mix design calculations. Thank you.